So we are going to talk about binomial distribution now, and it's one of the two important distributions we are going to study in this course. A binomial event is where there are only two possible events. So it's not, 4 or 5 different things that can happen, but only two, a yes or no. So basically that answer. So for example, if I just flip a coin, I can either get heads or tails. Or for example, in this case, the example we have picked up is called acceptance sampling. Here we are testing an equipment to see whether it's defective or not. So yes or no, whether somebody will turn up in an airplane or not. So that's another example we'll be shortly seeing. So let's look at this kind of examples. And your firm purchases electrical components from a large supplier in batches of 5,000. So this is the way the shipment is done. You get big batches of 5,000 components at a time. Traditionally, 20% of all units delivered have been faulty, and it's an acceptable level. So although it may seem a little bit on the higher side, 20%, but maybe these are things you are getting very cheaply manufactured somewhere in the Far East, and so it really does not hurt you till it gets to that level, exceeds 20%. So up to 20% of faulty equipments, you will accept the shipment. So you have received this shipment now, and as a quality control manager, let's say you have to determine whether the shipment is overall acceptable. That means you have at least 20% or less than 20% items that are faulty in that shipment. But remember, if it exceeds 20%, you are not going to accept it. So how would you decide if you are not able to test all 5,000 components? Testing all 5,000 components would be very costly, as you will see when we get to the sampling module, that we obviously rely on small samples because it could be very time consuming in this particular case to test all 5,000 components, and you don't have that time. So you randomly sample 10 components. That means you randomly pick up 10 components from that batch of 5,000 things, and you test them. And you record the number of defectives, all right? So let's call it number of defectives as X. And suppose that X turns out to be 3. That means 3 out of 10 components you have tested turns out to be bad. So percentage of defectives in the sample, obviously, you can see 3 out of 10 equates to 30%. So now you got, in your sample, 30% of components which are defective. But based on that, can you just return the shipment? Because remember, you have just picked up 10 components out of overall batch of 5,000. So you may have just picked up a sample which is bad. That's one possibility. So we will not be too hasty in returning the shipment, obviously, because we know if we pick up another 10 components randomly, you may not land up with exactly another 3 defectives, and that number could change. So in case of, in this particular case, the critical question you have to ask is that if everything is okay, if the batch is fine, that means in overall 5,000 components, 20% or less are defective, how likely it is that you will get a sample of 10 where 3 will turn out to be defective, okay? That is very critical to find out that likelihood, that probability. Okay, if that likelihood is really large, that everything being good, you still land up with a sample which has 3 bad components. If that is pretty large, then you will possibly hesitate to return the shipment. But if that probability is very, very small, you may say that, well, this is a very unlikely event, and since this has occurred, there must be something wrong with the shipment, and you may like to return it. So our question is that what's the probability that we will be landing up in that kind of situation where we have 3 out of 10 coming up as defective, okay? If everything is okay in the overall population or the overall shipment of 5,000 components. So these kind of things could be answered in Excel using a particular function for binomial distribution. So we will just go back to Excel. Okay. So in Excel, there is a function which is called binom dist. So just open any worksheet on Excel, and if you just click on the function menu here and choose the function which is called binom dist. Now you can type in binom dist here and try to search it, or you can go for function like statistical, a group of functions called statistical, and then find the function we need, which is binom.dist. So click on that, and you'd be asked to provide a few inputs here, and which are fairly simple. Based on a problem, the first input is, what's the number of successes in trials? Now in this case, success is something which is defined as, not in literal terms, but in terms of what we are looking for. In this case, we are looking for defectives. So basically, success would be the number of defectives here, because we are looking for defectives items. So in this case, we have 3 defectives. So I'll just use that number 3. And number of trials, which is exactly the number of trials we conducted. In this case, 10. So we had 10 trials with 10 components. So I'll put number of trials as 10. The next field is the probability, which is the expected defectives or chance of having a defective in each trial. So as our starting assumption was that 20% or less would be defective in this shipment, so the probability is basically 20%. So that's what we are expecting. We are not expecting to see beyond 20%. So let's put 20% here. You can either type in 20% or simply write 0.2 or 0.2. Whichever is convenient. So 20% is the overall chance of finding a defective, okay, if everything is fine, if the shipment is fine. The last one, the last field called cumulative, deserves a little bit of attention. You can put either 0 or 1 in this field. It only accepts 2 numbers, 0 or 1. 0 stands for no and 1 stands for yes, or you can say true or false kind of situation. It is asking whether you want a cumulative probability or not. A cumulative probability would be the chance of getting 3 or less, okay, out of 10. It's because it's a cumulative probability. But if you just use no, or if you say, no, I don't want a cumulative probability and put a 0 there, then what it will give you is chance of getting exactly 3 out of 10. Okay, and if you use the other one, which is cumulative, and put 1 there, then it will give you a chance of getting 3 or less. But remember, our problem here is slightly different. We want chance of getting 3 or more. However, binom dist always gives you the chance of obtaining a certain number or less than that number. That's the way Excel has develop this function. So in this case, I'm not going to, if I use 3, for example, and say cumulative, what I obtain is something which is not what I want. I get 87%, which is the chance of getting 3 or less, remember. But my problem here is to find out the chance of getting 3 or more from this sample. So I have to really modify this binom dist equation. So basically, if you just go back once more and modify this and change this number from 3 to, let's say, 2, which is what exactly I'm going to do. If I use a number like 2 here, and what I get is the chance of getting 2 or less now in a sample of 10, and that is 67%. So chance of getting 3 or more would be the complement of that. If chance of getting 2 or less is 67%, chance of getting 3 or more would be basically 1 minus this probability. So I'll do a little more modification. I'll go to the formula bar and type 1 minus this, 2 or less probability. And the answer would be 32% in this case. So chance of getting 3 or more is 1 minus chance of getting 2 or less. as defective. So anyway, so what we have found is 32% chance of getting 3 or more, even if everything is all right in the shipment. Now, based on this, can you return or not return the shipment? That decision lies with you. Do you regard 32% as a big number, big probability? That is a subjective thing for people. For most people, I would say they would not return the shipment because they will regard it as a fairly large chance, because 32% is almost 1 in a 3 chance. That means if you do this experiment 3 times, in one case you'll find out that even if everything is okay, you will land up with a bad sample where you'll find 3 or more defectives in a sample of 10. So they may not return it. However, if this number was not 32% but 3%, then more people would be inclined to return the shipment, because 3% is it's a slightly unlikely event to happen. Anyway, even if it is 3%, people return it, they will still be taking a small risk that the shipment was okay, because there was a 3% chance that the shipment was okay. But most people will possibly live with that risk, whereas most people would not like to live with a risk of 33% of things being okay and still returning the shipment. So there is one more example. If you go to the blackboard and look at the airlines example here. And so this data is given under overbooking spreadsheet, and you know the case of where airlines basically sell more tickets than the number of passengers they can accommodate in their aircraft. And the reason airlines do this is because they want to boost their profitability, and obviously by their experience they find that some people are always going to cancel their tickets at the last moment or not show up, and those seats will go empty. So the revenue lost for the airlines would be lost forever, and that happens for all service sector. If it's a hotel and if the rooms are empty one night, that's revenue lost forever, because it's not like a manufacturing sector where you can sell the product the next day and get the revenue. So for airlines, it's a loss to or it's less revenue when seats go empty. So based on that assumption, that probability of people not showing up is 10% in this case. They've made an assumption, and they have aircrafts which have 200 seats. They decided to sell more tickets. Like in this case, they decided to sell 215 tickets. Okay, so there is a good chance now that even if some people don't show up, they may be able to fill up the aircraft or try to get as close to that position as possible. However, there is also the other side of the coin, which is a small risk or significant risk that some more customers then will turn up, like more than 200, and they may not be able to accommodate all customers, and they have to turn down people who are still having tickets, and that can really give a bad name to the airlines if that happens quite frequently. So you want to know how frequently that kind of situation can arise if you sell more tickets, okay? And in this case, 215 tickets were sold, and you can see that the chance of at least 190 seats being filled up is given here. So if you just click on the cell and look at the formula bar, what we have done is use binomial dist function here to assess the probability of 190 seats being filled up. And again, binomial dist always gives you something less than a number. So when we are talking about 190 or more seats being filled up, we have used binomial dist with 189 seats, and that's basically gives you the probability of 189 or less seats being filled up. 1 minus that is the chance of at least 190 seats being filled up. And so which is 82%, which is really good for these airlines, because they were having 10% seats going empty. And in this case, they have really improved that situation. And even chance of filling up at least 195 seats have gone up. Again, click on the cell and look at the formula here. and see the same thing we have done here is just change the numbers from 189 to 194 now, because we are looking for chance of filling up 195 or more seats. And that has also been, quite decent, 42%. So of getting operating in full capacity. However, the undesirable situation is where more than 200 people show up, and there is, a problem, a customer service issue there at the airport. So chance of more than 200 people showing up, again, we use binom dist, and in this case we put 200 there because that gives us chance of having 200 or less number of people showing up. 1 minus that is chance of more than 200 people showing up. And that's 5%, so it's not an insignificant chance. So 5%, that means, 1 in 20 chance of having a customer service issue at the airport. Now, the airline's management may think, okay, if it's, 1 or 2 customers, we may be able to handle the situation at the airport. But what's the chance that more than 5 people will show up? Or more than 205 people will show up. In that case, we have 5 or more irate customers, and that'll be way too many to handle. So again, you can assess the chance of more than 205 people showing up using binom dist function and putting 205 in the function, and there's a 1.001. Which is basically 1 in 1,000 chance of that happening, that more than 5 irate customers at the airport whom the airlines have to convince some way or compensate in some way. So 1 in 1,000 chance. So airlines may think, okay, so this is a really bad situation, but it can happen only with a probability which is very small. So 1 in 1,000 chance of this happening. So if we have 1,000 flights, in one case, we may land up with such a situation. So they may think of that as an acceptable risk. But again, it depends on really the risk aversion of the management. And we can see, similarly, giving you all different situations from airlines selling different tickets, 206 to 233. Okay. So see from there, we have computed all the numbers here for you using binom dist function. See where you were comfortable with as a manager. Okay, how many tickets you are going to sell? Is it 218, which will really boost your possibility of filling up seats, or even 221, chance of filling up the whole aircraft is going up as you sell more and more tickets, but chance of having irate customers at the airport is also going up that way. You can see that. So depending on their risk aversion or aggressiveness of their strategy to boost profits, at the cost of long-term reputation, managers would make a decision. So the decision has to be made by you as a manager, and data analysis is not going to help you with that. But what it helps you is giving you different possibilities of different situations, so that you can make an informed decision in this case. Okay, so it will not give you what is the correct decision, but it will help you to make an informed decision. You exactly know by how much you can boost your profitability. You exactly know what kind of risk you are getting into in doing that. Thank you.